Yes, our topic today, we are talking about sterilization. Now, what is sterilization? You know, when we talk of sterilization, medicine sometimes will tell you that sterilization is making somebody not to ever reproduce again. But sterilization here in microbiology, we are talking about freeing all the materials to make all the materials free from all forms of life, those microorganisms which might be present. We want to get rid of them completely, killing them, remove or killing of those microorganisms is what we are referring to as sterilization. Now, on the same topic of sterilization, we want to know the different the classification of sterilization. Now, we on classification of sterilization. There is physical, there's physical sterilization. We classify them into physical and chemical. Under chemical sterilization, here you can classify them into, we have gases, and here we have the liquids. We have gases, we have liquids under chemical sterilization. Now, here under gases, we have one we have an aldehyde we call formaldehyde. We have a gas we call formaldehyde. Sometimes it is what we use. We have another gas which we call ethylene oxide. We have another gas called ethylene oxide. We have also another gas which we call nitrogen dioxide. Nitrogen dioxide. And also we have ozone. These are gases which we use for sterilization. Then also under liquids we have glutaldehyde. This is under liquids. We have glutaldehyde. Under liquids, we have also hydrogen peroxide. We have also hypochlorite. This one we normally go to the locally here. We normally go and buy jig. This is what we go and buy as jig. The hypochlorite. So this is categorizing under chemical sterilization. Then we have also this side. This side we have physical sterilization. Let us categorize physical sterilization. Under physical sterilization, we have what we call, one is heat. We have heat sterilization. We have another one, which is we have radiation. We have radiation. This is a physical sterilization. We have also filtration. Now, this one, under heat sterilization, this one is subdivided into we have moist heat sterilization. Have moist heat sterilization. We have another class which we call, this is moist heat sterilization. Then we have dry heat sterilization. So you are getting me? Are you getting it? So this is it, moist heat sterilization, dry heat sterilization, that is under heat sterilization. Then we also have radiation. This radiation we have non-ionized and ionized. Radiation, sterilization. We have ionized and we have non-ionized and ionized radiation sterilization. Under radiation sterilization. So let us try to pick one for today. We talk about it briefly, then we continue. In details, heat sterilization. When you look at heat sterilization, we have moist heat. We saw that we have moist heat and dry heat sterilization. So let us first look at moist heat sterilization. We are looking at moist heat sterilization. So under moist heat sterilization, we have here we usually use an autoclave. Autoclave, it works on a simple principle. The principle of an autoclave is just talking about three things. One is the pressure. Two, we talk about the temperature. Three, we shall talk about. So in this, the way it works, the way an autoclave works, it works in the way that we want to get the temperature. Usually we use water, and this water is used to create steam, and we use the steam to sterilize the microorganisms. Now, how do we increase? There are some microorganisms which survive. The boiling point of water is 100 degrees Celsius. But we want to, there are some, but if it boils at this point, we shall kill the microorganisms. But there are some microorganisms which do not die at these degrees. Some may reach at 110 degrees Celsius when they are still alive. What do? What we do is to increase the pressure. Once we increase the pressure inside the autoclave, we shall increase also the boiling point of the water we are using. So we increase this pressure to like 15 pounds per square inch. And such that when we increase it like this temperature, the boiling point will increase from 100 to 121 degrees Celsius. Then we also talk about time. So we have increased our pressure at 15 pounds per square inch. So we have now, it has made us to increase the boiling point from 100 degrees Celsius to 121 degrees Celsius. And we shall expose this to 15 to 20 minutes. We shall expose these microorganisms to this condition for 15 to 20 minutes. So the principle is water in an enclosed vessel in the autoclave is pressurized at 15 pounds per square inch to increase the boiling point of water to 121 degrees Celsius, and we time it at a time of 15 to 20 minutes. This will result into production of a steam, which is too hot enough to penetrate into the microorganism and be able to coagulate the proteins in the microorganisms, hence killing it. So that is how our principle comes about. We shall look at the autoclave in details. So secondly, we talk about dry heat. Dry heat sterilization. Dry heat sterilization. Here, with dry heat sterilization, you find that we have different categories here. We have flaming. Here, flaming. This is just, we use usually wire loops, which we use for streaking or inoculating microorganisms to the medias. So we just re-put the wire loop we are sterilizing direct to the flame. That's why we call it flaming. We put it direct to the flame and we burn it. We have under dry heat, we have another one called, we have the use of incineration. Now with incineration, this one is just real. These are the most cases we burn things which we are no longer in need of them, and we ban some other things like we can ban needles prior to disposal. We ban things, then later we dispose them to the final destination. Or we ban, we have a special area where we get the incineration, we ban those things. We have the incinerator, which we use for incinerating. So we burn. After burning, real burning, after they are decomposed, then we dispose of to the final destination. Then we have another one. We have the use of hot air oven. We have the use of hot air oven. The hot air oven, this one we use for, this one we, actually we shall talk about it in details in our next videos. It is somehow also lengthy. So that is short. That's the short part of it with the dry heat sterilization. So let us look at the radiation. With the radiation, we have two types here. We have one we call the non-ionizing. We have the non-ionizing radiation sterilization method. Non-ionizing radiation sterilizing method. This non-ionizing radiation, this one we use ultraviolet, which enters the, we use ultraviolet rays which penetrate and enter the and be absorbed by the nucleic acid in the microorganisms, and then they form a pyramid. They form, ultraviolet form pyramid dimers. Ultraviolet rays form pyramid dimers. These pyramid dimers, they will form on the DNA strand. On the DNA strand of the microorganism. This will lead to replication error. And this after leading to replication error, hence death of the microorganism. Then we have also ionizing radiation sterilization. With this ionizing, this one we use rays like X-ray or gamma ray. X-rays or gamma rays. These ones, once they penetrate and enter into the inside of the microorganism, they create oxygen reactant species like the hydrogen peroxide and superoxides. These ones, they then oxidize internal organelles of the microorganism, hence death of the microorganism. And then sterilization has now taken place. We have also we have another one, which we use the waves. We have the one that we use the sound waves. Sound waves. Here where we use the sonic waves, which and we use them in the liquids, and they create the cavities, which later collapses to kill the microorganism present in the liquid. Let's talk about filtration. Filtration. This one uses pores, small membranous pores, whereby the liquid is allowed to pass through, and the bigger particles and microorganisms are left out and shaved out. So that is filtration. So it has 3 steps, which is sieving, adsorption, and trapping. Sieving, adsorption, and eventually trapping. We have also fractional sterilization. It is sometimes called Sterilisation. Here, it is also under physical sterilization. Here, the media we are sterilizing, we sterilize it at 100 degrees Celsius. It was discovered by a man called Tyndall. So that's why it's called Sterilisation. It comes from Tyndall, the name, the man who discovered it, the name was Tyndall. So, Sterilisation, we Tyndallize at 100 degrees Celsius. We boil the liquid at 100 degrees Celsius for 20 minutes. Then after, we leave it to cool. Now that day, the first boiling will kill all the vegetative microorganisms, including the spores. Then the following day, we again boil at 100 degrees Celsius again for 20 minutes, such that those ones which did not die in the previous boiling will have grown, will have become vegetative, and they are now also killed that day. Then the third day, we do the same story, and the first that is the principle. Those which did not die on the second day will have become vegetative, and they die on this third day. It is good, but sometimes may not be effective to some thermophiles, because there are some thermophiles which don't die at this temperature, so it may not be effective for some thermophiles. So that is fractional or Sterilisation method of sterilization. Then finally, we have cold sterilization. Cold sterilization, this is whereby we include the use of some chemicals little temperature. We sterilize at a low temperature for when their medias need sterilization, but they are sensitive to high temperatures. So that's why we use that called sterilization. So don't forget to subscribe, comment and like. But first subscribe, then you comment your question. So you subscribe not to miss out our next topic, our next videos, because we are going to look at these things in details, and they are good for medical workers and medical students. Thanks for watching till the end.